Hello guys, my name is Prathamesh Madhav Kusram. My roll number is 16, my PRN is 202301040060 and batch is EDA1. So I am third year BTech student currently pursuing computer engineering from MIT Academy of Engineering, Pune. The subject is exploratory data analysis. Topic is optimization of loss function and best fit line using gradient descent. So, introduction to regression. First is supervised learning method. Regression is a statistical technique that models the relationship between variables to predict continuous outcome based on input feature. Second point is real world application. Used extensively to predict hours, prices, sales, forecast, temperature, trends, and stock market movement from historical data pattern. Third point is core objective. Find the best fit line that minimize the distance between actual data point and predict values, creating an accurate predictive model. The regression equation. First is mathematical foundation. Y equals to beta naught plus beta 1 plus gamma, where predicts output, depends variable, beta introspect, where the line crosses y-axis, beta 1 slope rate of change, x input feature independent variable, and gamma error terms. Visual representation. The regression line passes through a scattered data points with the interpret determining vertical position and slope, controlling the angle of inclination, scatter plot showing data points with best fit line, clearly marking beta naught on y-axis and demonstrating beta 1 through line angle. Understanding the loss function. What is loss? Loss quantifies the prediction error by measuring how far our model predicts deviate from actual observed values in the dataset. Mean squared error, MSE. MSE is 1 by n summation of n to I equals to 1 yi minus yi square. The most common loss function that square difference to penalize large error more heavily than smaller one. Visual interpretation. Diagram showing vertical lines between actual data points yi and predict points yi on the regression line, illustrating individual error. Why minimize loss? First point is the optimal goal. Lower loss value indicates better model performance by minimizing MSE, which adjusts parameter to bring predictions closer to reality. The relationship between the parameter values and loss forms a convex cost surface with a global minimum are target destination. Lower loss, better prediction and model accuracy, higher loss, poor fit and unreliable forecast. The cost curve. U-shaped parabol parabola showing cost function j beta on y-axis versus parameter beta on x-axis with a minimum profit point marked on bottom of curve. This convex shape guarantees a single optimal solution that gradient descent can reliably find. A gradient descent, the optimization engine. First is iterative method, an algorithm that repeatedly adjusts parameter to progressively reduce the loss function until reaching optimal value. Initiative analogy. Imagine a ball rolling downhill, it naturally moves toward the lowest point. Minimize loss by following the steepest descent. Convergence. The process continues until the parameter changes become negligible, indicating we reached the minimum. The gradient descent update rule. First is update formula. Second is learning rate. Controls the step size at each interpretation. Typically value range from 0.001 to 0.1, balancing speed at stability. Third is gradient, the partial derivative indicating direction and steepness of slope. It tells us which way to adjust parameter and by how much. Iterative update. Parameter moves in the opposite direction of the gradient, getting closer to optimal values with each step. Linear regression via gradient descent. Initialize parameters start with a random or zero value, beta not equals to 0, beta 1 equals 0. Make prediction. Calculate predicted values using current parameters. Compute loss. Measure error using MSE formula across all training examples. Update parameter. Apply gradient descent rule to adjust beta naught and beta 1 based on calculated gradient. Repeat until convergence. Continue iteration until loss stabilize or reaches acceptable threshold. Impact of learning rate alpha. The learning rate is a critical hypermeter that dramatically affect convergence behavior and training efficiency. Optimal alpha. Just right smooth steady convergence to minimum a reasonable time with a stable oscillation. Too large alpha. Overshooting. Steps are too big, causing the algorithm to bounce around or diverge away from minimum. Too small alpha. Slow progress. Tiny steps lead to very gradual descent requiring many iterations to reach minimum. Talking about the conclusion, regression analysis, establishing mathematical relationship between the variables, enabling prediction of continuous outcome from input. Loss function, Quantifies prediction accuracy through MSE providing a measurable objective to optimize during model training. Gradient descent. Iterative optimized model parameter by following the gradient downing to minimize loss and improve prediction. Reference. These are the reference. Thank you.